Hello, my name is Emmanuel Nathan Chong and I'm here to explain you guys some maths that you guys might need some help with. I'm going to be explaining about further trigonometry regarding about sine rules and cosine rules and how to apply them using questions from a math book, apparently. I hope you will enjoy this video as much as I enjoy making it. The questions are taken from the mathematics books of Shingley, 3rd grade 7th edition. We will be discussing number 11 and 16 about further trigonometry from exercise 7c, and this is for you who do not know how to apply trigonometric functions, and also homework. This is number 11 from exercise 7c. Feel free to pause the video to take a look at the question. And here is the guided walkthrough of the answer to number 11. Now, as we see here, that we have two triangles, and one of them is right angled. So the first question, which is in this case AI, is asking for the bearing of A from B. Okay, so as you see here, this is A, and that's B over there. I got it a bit scribbled there because I was doing some ridiculous calculations that you don't want to look at. So in order to find the bearing is basically, if it's asking from the bearing of A from B, it means that we're supposed to draw another north pivot point. This wasn't there before, remember? And we were supposed to find this here. I marked it with some sort of circular like arrow. We're supposed to find that angle. So in order to do that, what we can do is first we find the angle of OBA, as I stated here. Now what I mean by finding angle OBA is that we can do an easy shortcut of finding the bearing by thinking that this is an entire circle, so 360 degrees, and then that there, I'm gonna zoom in. Hold on a moment. Alright, so this here is 90 degrees, and this, the entire thing, is 360 degrees. Now, the cut in the center here is perpendicular, so all we need to do is find this angle, and then we include in our equation later 360 minus 90 degrees with that angle. Now, that angle is angle O, B, and A. So how to find it? So we can use angle OBA equals to the inverted tangent of 28 over 30. You can simplify this by dividing them by 2 and getting 14 out of 15. Since they are basically ratios, it will be fine. The numbers won't change. In the end, after you do calculations, you'll get 43 degrees. Now, why did I use 28 over 30 with the tangent function? It's because, if you see here, 30 or OB is adjacent to OBA, and OA is the opposite of angle OBA. The formula for tangent is opposite over adjacent, which is why I used 28 over 30. You can simplify using 14 out of 15. So after getting 43 degrees, you can include in the previous equation I told you, 360 degrees minus 90 degrees minus 43 degrees, and you'll get 227 degrees. And that is the bearing of A from B. And on to the next question. The next question, of which is AII, is asking for the angle of COB. Now, if we look at the triangle again, so to make this clearer, I'm gonna zoom out a little bit more. This is C, this is O, and that's B. It's a triangle, and we're given all the lengths of the sides. What we're trying to find here is this angle, COB. As you see here, I already marked that out. That's the answer, but I marked it out because it might prove useful. Because you're supposed to, if you can fill in whatever information you can beforehand, it would be very helpful, rather than me wasting around 3 papers finding the answer and getting nothing out of it. And so to find COB, you need to use something called the cosine rule. So the cosine rule is basically something like, let me point it to you. So to find angle COB, we need to use this equation. So we need to find the length of CB, because CB is the opposite of COB. In this case, CB is 70. So we use 70 squared equals to the addition of the squares. So 50 squared and 30 squared. If you look at here, 50 squared and 30 squared. The addition of the squares of the 2 sides that connect them. The 2 sides that make up the angle of COB. And then after that, you minus with 2 multiplied by the product of 50 times 30, which is the sides that make up the angle, and multiply that by the cosine of COB, in which the amount we don't know. Now, this is basically a simple algebraic equation, and if you solve it one by one, you go down there, and then you solve it. COB has an angle of 120 degrees. Now, back to the next question. The bearing of C from O. Remember what I said about keeping 120 there? This is where 120 comes in usefully. So keep in mind, I'm gonna zoom in. It's asking of the bearing of C from O. That means you have to draw a pivot point of from O this way. So it forms this one straight perpendicular line. Keep in mind, it has to be perpendicular. We know that this is perpendicular. This is perpendicular as well. And then if we were to form an extension of this line here and like make a bridge over there, let me draw it. That would also be 90 degrees. So 90 degrees and 90 degrees. Now, an easy way of finding the bearing, since the bearing is whatever going clockwise, so the thing we're supposed to find here is this. That angle. Now, an easy way to do this is that knowing first the angle CON. Okay, now let's take a look at angle CON. How do you find angle CON? This angle right here. Basically, what you can do is that since you know that this is 120 and that is 90, you can just subtract them and you'll get this angle CON. And as you see here, I've made the answer, I've counted it, and it's 30 degrees. What you can do after that is that since the entire thing is 360 degrees and that's the only thing separating the line CO from NO, the angle there makes a difference. So what you do is to count the bearing, you simply just do 360 minus 30 equals to 330 degrees. And that's the answer. We're still in number 11, but there is apparently an 11B. It's stated that the height... it stated that the 3 points C, O, and A and the other points are placed horizontally on level ground, and that there's a flag placed in point B. So don't imagine N as the flag. I've made a separate diagram for it. So it is measured that the angles of elevation to the tip of the top of the flag from C, O, and A, and that the greatest angle of elevation of the three of them is 29 degrees. If you look closely at the drawing, logically, the one that would have the greatest angle of elevation is the one closest to point B. Now, how do we know which one is the closest? The key is, C here has a 70-meter difference. O has a 30-meter difference. What about A? That's even simpler. We know that this is a right angle triangle, and A is a hypotenuse, so it's the longest length in the right angle triangle. That means O has to be closer than A, sorry. And that also means that O is also closer to B than C. So that means O is the closest to B. If we make a diagram, we would have this. So that's top of the flag there. This is B, and that's O, 29 degrees. A with a smaller angle, and C with a very acute angle. We don't need to know the rest of the distances anymore, because this is what we need. Now, what you should do next is, using the cosine of 29 degrees, we can conclude that the height of the flag over 30 degrees equals to the cosine of 29 degrees, because in here the flag works as the opposite, and 30 meters works as the adjacent. So, whoops, I think I might have made a mistake here. I should not have used cosine. I should have used tangent. Now, remember that the height of the flag is opposite, and 30 degrees is adjacent. Don't make the same mistake I did and used cosine instead. Don't forget that the hypotenuse is always the diagonal length. Now, if we can just remove all the coses and replace them with tangents, well, you can figure out the answer will not be this. And so, in conclusion, I have corrected my answer to be 16.63 meters of height. I can guarantee you that these answers are correct, because if you compare them with the answer key, they're either maybe a tad bit of difference, like rounding up decibels maybe. If you keep things, maybe you round up something in the middle, but all of these are the same with the answer keys. This is question 16. Keep in mind that there are 3 right-angled triangles in here, and from a 3D perspective point of view. Here is the answer to number 16 that I have prepared in advance, same as I did for number 11. So apparently, you will be extremely confused when you first look at this question, because I wasted a total of 10 hours and 58 minutes trying to find the answer to no success. And I apparently did something wrong in the algebraic equation, blah 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 blah, and eventually I just found the answer. So out of the question itself, we can make out 3 triangles. So the first one is that this is O, this is T, and that's B, and the angle of elevation is 40 degrees. The second triangle is the same thing, but from a different point, O and C. Keep in mind, we were not given any of the lengths, only the angles. The next one is T, O, and C. Angle is 25 degrees. And the third triangle, which is the distance separating OB and OC, which is 70 degrees. And this is a right angle triangle, as it is stated in the question. And keep in mind, in here, we are not given any angles. We're only given 70 meters as length. Out of these 3 triangles, you can form 3 equations that lead you to the answer. And these are the three equations you can form out of it. So the reason why I used 1 and 2 here is because basically OT and OT are the same thing, just which one belongs to which. So OT1 from triangle 1 is equals to OB multiplied by the tangent of 40 degrees. And OT2 is OC multiplied by the tangent of 25 degrees. And OC is the square root of the sum of OB squared plus 70 squared. Now from these three equations, we know that the OT is basically the same thing. So OT1 and 2 share the same value. That means OT1 would definitely be equal to OT2. So we input the things we know about it. OT1 is equal to OT2. So OB multiplied by the tangent of 40 is equal to OC times the tangent of 25 degrees. And we move tangent 25 degrees over there because the relationship between these two is multiplication. If you want to move it under there, it becomes division. So you can say that it becomes OB multiplied by tangent 40 divided by tangent 25 equals to OC. Now what do you do with the OC? Well, you just input this. OC, it is stated that OC is the square root of the sum of the square of OB plus the square of 70. And then we get this here. And make sure you count the value first. Count the value of tangent 40 divided by tangent 25 first, so you won't get confused later on. So after this, after we count the value, we move down here. Now what happened here? What we did is that previously there was a square root over there. We moved it there and it becomes a square, not a square root anymore. So we square root this. And therefore, this one you can just count it normally. So 70 squared becomes 4,900 and OB squared stays OB squared. Okay, now we got this now. Then we go to the next line. 2.236401 OB squared is equal to 4,900. Now what did I do here? So from this equation, you do it like this. So apparently, remember the OB squared on the other side? You move it there. But then since this was positive, and the relationship with this one is not multiplication but also addition, this one, if moved here, becomes negative. So you minus it. You subtract it. So 3.236401-ish OB squared minus OB squared, which is basically 1 OB. And it becomes that. Equals to 4,900. Now you go to the next level and, well, you can kind of see what happens. So this here, I moved it over there. The relationship between this and this is multiplication. So when moved there, this one will divide that. So it's 4,900 over 2.236401 equals to OB squared. Then you move the square here into a square root on the other side. And you would get the result, OB is 46.8 meters. Now moving on to OT, since they didn't only ask OB, they asked for the tower's height too. So what we can do, since we know the perfectly complete picture now, is that you can explain that OT will be equal to 46.8 times the tangent of 40 degrees. Well, the original from this was basically the tangent of 40 degrees is equal to OT over 46.8. Oh, sorry, put a double 8 there. And then you can kind of guess what happens. Oh, and after you do the calculation, do not round anything up. Leave it as it is in your calculator. And round this one up. Round 6 up. or if this was 5 and this was 9, you basically round the 9 up. Or let's say this was 4, okay, let's say the 6 was 4, you round the 9 up, this becomes 5, then you round the 5 up to the 2, and it becomes 39.3 meters. And there you go, that's the answer for number 16. If this video was somehow useful to you, and you find it quite pleasing and satisfying enough for your answers towards these questions, if you don't mind, please drop a like and comment. And if you want to subscribe, feel free. I am welcome to anyone who wants to subscribe to my channel. And please support by spreading this video to other people who might need this video, because it can be extremely helpful for people who don't understand this topic. Thank you and goodbye.